Cloud data leakage is not just a storage problem. It is a key ownership problem. When sensitive records leave a trust boundary, encryption changes the impact only if the keys are controlled, monitored, and owned before the incident. Encryption is not enough by itself. A cipher protects data, but the architecture decides who can use the key, who can change policy, who sees decrypt activity, who rotates the key, and who can recover after a mistake. Provider-managed keys are simple and fast. They are often the default path because the cloud platform handles more of the lifecycle. That may be acceptable for lower-risk workloads, but it gives the provider-managed service more control over operations and evidence. Customer-managed keys shift more accountability to your organization. You own key policies, rotation decisions, separation of duties, and deletion risk. That gives stronger control, but it also means your team must engineer the policy correctly. External key management goes further. The cloud workload asks an external vault for key operations, sometimes called bring your own key or hold your own key patterns. This can improve independence, but it adds latency, availability dependencies, and incident response complexity. The real door is IAM. Most key failures are not broken cryptography. They are overbroad principles, wildcard permissions, missing conditions, weak approval flows, or admins who can both change the key policy and read the data. Here is the leakage scenario. A storage bucket is exposed and data is copied. If the attacker cannot use the key, the incident may be contained. If a compromised role can decrypt, the same exposure becomes a much larger breach. For SecurityX thinking, evidence matters. You need logs for key policy changes, decrypt attempts, denied calls, rotation events, and owner approvals. Without evidence, you cannot prove that key control worked during the incident. Now, test the decision. A regulated analytics platform stores sensitive data in cloud object storage. Which key model best supports independent control and provable revocation? A. Provider-managed default keys. B. Customer-managed keys with strict IAM and logging. C. Plain hashing of records. D. Public bucket plus TLS. The best answer is B. Customer-managed keys with strict IAM and logging do not remove every cloud risk, but they give the enterprise better control over policy, revocation, audit evidence, and ownership. The SecurityX takeaway is to design encryption as a key control plane, not a checkbox. Decide custody, policy, monitoring, rotation, recovery, and revocation before data leakage happens.